This map here is showing the annual population growth. In blue, you can see that it's less than 1%. And if we're looking at population growth, what is the variable? Yeah, we're looking at R. So this variable. So you can see here United States and Canada, a lot of European countries, Russia, China, Australia. Those are some of the countries that have less than 1 population. Then looking at between 1 and 2% population growth, you can see here in the green. And then the highest growth of all other countries tends to be on what continent? Yes, very important. Hint, hint, wink, wink. The population of the continent that has the most amount of growth is Africa. Trends and implications. There are several factors. There are several factors determining the impact of a society on natural resources. You have population size, larger demand on resources as you increase in population size. Population density, higher density causes more problems. It's more people condensed in a small area, like cities. And the degree of technological development, affluence and increased resource uses. What's affluence? Yeah, that is the individual wealth. Factors that influence population growth, biological factors. I keep swiping this thing. Biological factors like demography, which is the study of populations and their characteristics. Birth rate usually exceeds death rates. There's an ultimate carrying capacity for the human population. And unlike other organisms, we have accumulated knowledge and can adjust our lifestyles and impact accordingly. Other biological factors are the TFR, total fertility rate, which is a term that you'll be seeing quite often. And this is the number of children a woman has during her lifetime. Replacement level fertility, the number of children needed to replace everyone in the population. Varies between regions, but on average it is about a 2.1. And then zero population growth, which the birth rates equal the death rates. And then age distribution, which we'll see here in a second, the number of people at each age in a population. And there are some great videos on the additional videos explaining each of these in more detail. Doubling time! This is one of the math problems that shows up probably about 5 questions on the AP exam is calculating doubling time. Well, before you calculate doubling time, you have to calculate R. And how do we calculate the rate of growth of a population? Yeah, we have to do the births minus what? The deaths. Or the rate, if we're looking at just one country, is, here, I'm going to take these out. I'm going to make this smaller. I like my erasing noise. Alright. So, just of the world, we're looking at rate equals births minus deaths. But if we're looking at just an individual country where people can come in and out, it's the births minus the deaths plus what? Yeah, immigrants coming in versus immigrants, people leaving. So once we calculate R, we can calculate doubling time. Doubling time is the time that it takes for a population to double in its size. And to calculate this without using calculus, you can use the rule of 70. So once you've calculated R, you take 70 divided by your R. Now your R is going to be a percent. But you leave it, here's the weird thing, you leave it as a percent. So say we calculate our births and deaths and we get a percent of 3.5% growth. Now to find doubling time, you keep it as 3.5 and you do 70 divided by 3.5. And that would give you how long it takes for a population to grow. how long it takes for a population to double its size.